In this video, I will demonstrate how to use uniTank to register several external datasets. Before we begin, I want to show you some manual manipulation tools that may come in handy as a last resort. If you hold down Ctrl and Shift and drag with the left mouse button, you can move a layer around. The layer you move is determined by the selected layer in the drop-down menu. If you hold down Ctrl and Shift and drag with the right mouse button, you can rotate a layer. The amount of rotation depends on how far your mouse is away from the screen center. If the Rotate About Origin checkbox is selected, the layer will rotate about 0, 0, or the orange dot if you have it showing. If the Rotate About Origin checkbox is not selected, the layer will rotate about the view center, or the green dot. We're going to start off with the simplest external registration case, which is a tank among other tanks. In this scenario, there is a lot of auxiliary structures to help with registration. The process follows much like the interior registration case, but with a few added steps. First, we need to estimate the tank diameter using one of the scan layers if we don't already know it. Then, we must perform auto-register. Make sure that the Scanned from Exterior checkbox is checked and the tank diameter estimate is accurate. While we wait, I'm going to explain the single versus multi-tank option in the auto registration dialog. The multi-tank option is the better choice for scenarios where there are several tanks within the scan area that have similar diameter. In such a scenario, the single tank option may get confused as to which tank is the tank of interest. We typically use this option for registering berm data. You can try both options and see which one gets you closer to an initial registration. So for external course registration, it is important to refine the course registration. What we do is we run Translate, Rotate, and Elevate separately with the Refine option. When doing Refine Translate, we want to put our best estimate of the tank diameter if we know it. With external scans, the diameter estimation from a single scan is not always accurate depending on the coverage area of each scan. Next, we want to do a refine rotation using a horizontal cross-section with as much asymmetry as possible. So look around at different elevations. Sometimes it may be at the berm elevation, sometimes it may be where there are some pipe features, and sometimes it may be high up where we can see the other tanks. The important part is to pick an elevation that has unique features in each scan that can be used to correlate the rotation. If the course rotation or translation was noticeably off, it is a good idea to run Elevate again to make sure the elevations are properly matched after the adjustments. Next, we will proceed as like in the internal registration case and automatically add fiducials. Again, ensure that the Shell Scanned Externally checkbox is checked. The automatic fiducials will try to add horizontal fiducials on surrounding tanks. However, if the terrain is drastic, it may add horizontal fiducials on ground areas we don't want them. If this is the case, simply delete the fiducials that you feel will not help the registration process. We want to use surrounding tanks as much as possible. Due to the noise level in some of these surfaces and separation between scans, fiducials may not always get placed on them. Manually add horizontal fiducials on surrounding tanks if they are missing. Make them nice and big so that the fiducials overlap the tank in all layers. Now run snap fiducials. With externally scanned tanks, there may be a lot of movement required, so you may need to run snap fiducials a few times to get the layers to converge really tightly. In the second scenario, we will use the multi-tank auto registration procedure. Similar to scenario 1, we will refine the quartz registration and rotation afterwards. It looks like that the auto fiducials tool picked up the surrounding tanks quite nicely. Similar to last time, we will delete some of the fiducials that were automatically added that we don't think will help registration. What you will notice is that we have some weakness in the bottom and right sides of the registration because we don't have any surrounding tanks there. In this particular case, we can use the support columns of the spheres as column fiducials. If we find that the right side of the registration is still weak, we can use the berm as horizontal control. We typically only use the berm as a last resort because they often are covered in vegetation and are not very steep. However, if we need to use the berm, we can simply place fiducials along the sloping side of the berm. We want to use areas that appear relatively smooth and that have overlap between layers. We can also use structural objects in areas such as buildings, cars, pipes, containers, etc. As long as they are smooth, vertical, and overlap between the layers, we can use them as fiducial control. The last scenario we are going to look at is the most challenging external registration case. In this case, the tank is on its own and there is little surrounding structure, and the berm is too shallow or rough to use. So for this tank, after we have done auto registration and refined the translation, we find that the overlap between the scans is insufficient to get a good coarse rotation. If this is the case, we can simply manually rotate the layers into place, and we do this by using the Control Shift right click and drag feature. Once we have rotated all the layers into place, we perform a refine translate followed by an elevate to ensure all the layers are in place. On this tank, I'm going to manually add fiducials so you can see the process of picking your own fiducials. First, I will draw a circle around the shell at around the 3 to 4 foot elevation and create horizontal surface fiducials. Instead of using the floor for vertical surface fiducials, I'm going to use the wind girder or walkway. Many tanks scanned externally will have some type of horizontal feature at the top that can be used for vertical registration if the floor is rough or covered in vegetation. If the system doesn't find all the fiducials automatically within the defined area, you can always add them manually using the point tool. Next, I will use the wind girder support flanges to add horizontal surface fiducials. Notice I am placing them closer to the tip of the flange. This ensures that the fiducial does not catch the shell data instead. I'm going to look at the ground level to see if we can find any other horizontal fiducial surfaces that may be suitable. Again, any smooth, flat surface that overlaps between scans can be used. This includes cars, containers, buildings, etc. If there is a lot of piping in the area, it can also be used. Just ensure that you place the fiducial at the vertical portion of the pipe. Ensure that the fiducial you make is small enough so that it only covers one side of the pipe. You can continue adding fiducials in the model to refine the registration until you are happy with it. Remember, if you run check fiducials, you can see if some fiducials are poor quality. If you find that your model is diverging, this is a good place to see if some of your fiducials are catching on separate surfaces.